For our next speaker, A. Sander, which
Hey,
was not
Sander.
the Sander who broke his leg, right?
Nope.
Or does anything...
Well, sort of broke my back, but
Please don't break our
no,
mic.
I'm good in breaking stuff, so.
Yeah.
All right, I'll hold it.
Yeah. Serverless lambdas,
Yes.
and it was really hip, I heard last week.
Yes, it's hip and happening, so.
Yeah, so please give a round of applause for Sander.
Hi, so this is me, I'm Sander. You can tweet me or look at my site. This talk is actually based on a blog post I did. And Jelmer saw the blog post and said, hey, maybe you can talk a little bit about it. So, yeah. You might also know me as Dr. Bendu, which is a side project of mine where we teach kids how to program with Raspberry Pis and Python and that sort of stuff, which is a lot of fun. So yeah, the blog post today was about serverless screenshots. Who in here is familiar with serverless and Lambda and that sort of stuff? Okay, quite some people. Not enough, in my opinion. So we'll see about that at the end of the talk, who's interested. It contains a lot of bullshit bingo, so bear that in mind. And serverless is awesome. So, look, mono servers. That's what it's all about, right? Not maintaining any hardware, that's always good. Not maintaining any operating system and that sort of stuff. I mean, that's all crud you have to deal with, but you don't want to. You want to focus on your application. And that's where serverless comes in, because serverless is awesome. It's also referred to as FAS, which is, of course, a nice abbreviation for functions as a service, same as SAS and PaaS and IaaS and whatever you want. And there's a nice tweet because it's cheap. So yeah, serverless. There's basically every cloud provider out there which actually matters has a implementation of a serverless function. So Google does Google Cloud Functions, AWS does AWS Lambda, and Azure does Azure Functions. They're basically all the same. They have implementation deals, of course, that differ, but I'm going to focus on AWS Lambda because that's the most obvious one and that's the most used one currently in the field. But don't miss out on the other ones because they have some features of themselves which are good. Yes, so the basic idea of a, let's go back. So these are functions, but actually there's more to a serverless than just functions. I mean, AWS alone also does like S3, which is their oldest API and oldest service. It's also serverless. There's stuff like Redshift, come on, I'm blanking out. There's a whole lot of services which are also serverless. You don't have to maintain any service, and that's the basic gist of it, which saves you time for implementing your application. So the basic idea of serverless functions is that they're stateless. So every function can be invoked, doesn't know anything about its state, it receives an event, it handles on the event, returns something. And then it's scaled again, and it doesn't know anything about up on the next invocation. In theory, the scalability is limitless, so you can spin up as much functions as you want, as long as your credit card allows it. And it's mostly used currently for microservice architectures, because it's really, it's nice mapping into those microservice architectures, which I'll give a demo of in a moment. And as I said, in the case of Lambda, it's always event-based, so think about someone uploads a file into S3, that will trigger a Lambda function, or someone puts something into DynamoDB, that will trigger a Lambda function, and you can act upon that. So in the case of uploading a screenshot, a thumbnail will be created of that screenshot, or in the case of someone inserting something in the database, maybe you can do some calculations on that. And that's all serverless, so no servers. You only implement the function itself, so you receive one-on-one, maybe the function itself does the addition, so and the response is 2, and then it's scaled again. Classically, you would of course do autoscaling, which is one of the nice features of Lambda. You would do it like this, so you have a load balancer, you have some servers, at least n is 2, right? Because you don't want to go down. And when you have a load on your service, you say, okay, if the load becomes above 75, I want to scale out, add some more service. But what will happen is, you have two servers normally. What will happen in the gray areas is that in those times when you only have two servers running, but there's not a lot of traffic, you're still paying for those servers. And of course, that's just throwing away money. So that's bad. So how does Lambda work? So Lambda, as I said, is event-based. So every time a request comes in, you can handle something. And if you get more traffic, it just spins up two more. If you have more and more, and up until a limitless amount of Lambda servers as functions. There's a nice quote saying, you pay for the hamburger, not the cow, which actually means so you're only paying for the invocation. So only the time you need to run the Lambda function, and the only, so the time the Lambda function takes and the memory it consumes is the only a variable that you pay for. And AWS is really nice about that. But I'll come back to pricing later on. So the actual demo. So this is a screenshot service. So I have a laser. Yay, lasers. So there's an application which wants to run, wants to take screenshots. And it has an API key which connects to an API gateway. That API gateway will only respond to that specific API key. There are three functions. There's a create screenshot, which obviously creates screenshots. There's a list screenshot function, which gives back a list of available screenshots for a URL. There's a bucket in which the screenshots are actually stored. And there's a function called create thumbnails, which will create thumbnails based on a screenshot of a URL. And of course, there's an end user who logs into websites, sees a URL, and downloads it through CloudFront, which is a CDN, which fetches the data from the S3 bucket. So how does that work? Demo time! All right. So if this fails, see? There we go. Dun, 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 dun. Let me mirror this. Bum, 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 bum. So much for preparation. Oh, there it is. Where's my mouse? No, there it is. So, mirror, mirroring. Yay. No. The other half is here. So, of course I should have opened this. All right. That's real, all right? Oh, yeah. So, serverless. Serverless, so in this case I'm using the serverless framework, which is really nice. Is this readable? Somewhat. Serverless is a really nice framework which you can easily use to deploy multiple Lambda functions. And in this case, it uses a YAML function, a YAML file to actually create your Lambda functions. So let me close these. So in this case, I have three functions: create screenshot, list screenshot, and create thumbnails. Those are the three that you also saw in the overall diagram. So create screenshots gets an event. In this case, an HTTP event. It has a path which it listens to, which is /screenshots. It listens to post, it's private, so you need the API key, and it has request parameters, in this case a query string with the name URL. And there's two more. There's also list screenshots, which is also an HTTP function, which has a path of /screenshots, which is a get, of course. It's private as well, and it also has a query string URL, which it needs, which is required. And there's create thumbnails, which is a different beast, because this is the actual one that responds to an S3 event. In this case, the creation of an object. Whenever an S3 object created function event triggers, this method gets triggered. and responds to a bucket which is in the environment. Yeah, that's about it. So, and the way you implemented it, there's a handler file with a lot of functions in it. Well, actually, just 3, which are mapped directly to the ones in the YAML file. So you can take a screenshot, which gets the URL, gets a timeout, that's an environment variable, checks if the URL is valid, and if so, creates a hash and runs Phantom.js, because that's the thing that's actually creating the screenshot, which creates a virtual frame buffer, opens a Chrome browser, opens a URL, and then takes a screenshot after X amount of seconds. So whenever that succeeds, it uploads to S3, and it returns the URL of the end location of the file, for the screenshot. So for this screenshot, it's basically the same. It checks if the URL is valid, and if so, it just checks in S3 if there's a list of paths, wow, with the correct URL, and it spits those out. And for create thumbnails, it's a bit different. So we set up which width we want to have, and we get the original S3 file from the event, which is something that AWS provides. And we check if this is an original, if this is not an original, then we don't want to create a thumbnail, because all the thumbnails, of course, also will trigger an event. And we can just skip those. Blah, blah, blah. And then for each file size, we create a thumbnail using Convert, which is image magic, which you get for free. And we upload all those to S3. So that's the basics. Of course, we also package in our binaries, in this case Phantom.js. So we have a Linux version over here. Oh, let's not open that. So there's a Linux version, an OS X version, and there's the actual screenshot implementation in Phantom.js. This you can just download from the net. I just downloaded it and added some scrolling into it. And that's basically it. So when you do this, let me see. So I can make a screenshot. So this is the URL. Interesting. So this is my endpoint. I'll show you the endpoint in AWS console in a minute. This is the endpoint. Is that readable? Interesting. So you get a URL from Amazon. This is the dev environment. This is the /screenshots that I was just talking about. I'm giving it a URL. I can send it. Oh, and of course I'm sending the API key, which I won't show for long.
It's in the video now, so if it's your
I'm gonna change it anyway. Yeah. Don't worry, but it's cheap, and I'll show you how cheap it is. So it doesn't really matter. So this is what I just told you. So we put in the URL, and it will return the hash that we provided in the source. So in this case, it hashed the URL, just 95. So to create an original directory just for the URL. It put it in this bucket, and this is the endpoint. So if you open up this URL, we'll see the Nipitana website. Yeah, it even works. Live demo, yay. Yay! So, and of course we can also get something different, I don't know. Start pagina. And now it of course will break down. Is it HTTPS or? Good. That should work actually. Yep. Come on. No. Where's my other window? There it is. Oh. There's the start line. As you can see, it was fairly quick. I mean, it took a couple of seconds. The most of the time is in the Lambda function actually connecting to the endpoint because it's coming from Ireland. It's fine. So the next thing that I wanted to show is, so we can now also list the screenshots. So show the screenshots for nu.nl. So this is the one that we just made. So we just invoked it, and then Lambda was triggered by S3 to create all these screenshots based on the definition I made. So we can just pick one. Let's say, let's pick this one. Ah, come on. There we go. And it will just get me the thumbnail version of it. And there's also, like, say, which is just a rescaled version of the original. So yeah, there's that. So how does it look? Does this look in the actual account? Yes. Hold on. This is actually secure, so. Come on. Quick, quick. There we go. So, how does this look? So, API Gateway. We have an API called Lambda Screenshots, which has an endpoint /screenshots, which has a get and a post, which require an API key. Oh, what else do I want to show? There's dashboards where you can see the invocations and all the latency and all that. And of course, there's the Lambda functions, which is actually the interesting part. So, no, what was it called? Lambda. There we go. Take screenshot. So this is the code. You can actually see it in here because it's too big. Well, it thinks it's too big. You can see the logs. And there's no logs. Why are there no logs? Why are there no logs? Live demo, right? Why are there no logs? It doesn't make any sense. All right, let's skip that. So it does that. You have the logs. Awesome. So as you saw, it took like a couple of seconds to create a screenshot. So what does it mean for cost? Because that's one of the other cool features of Lambda. It almost costs nothing. So you get 1 million requests per month for free, which is quite a lot. You won't hit that. Well, not on your dev server at least. And you get 400,000 seconds per month for free. Per month. So in this case, that and a call costs you 0.000002 cents per call, dollar. So if you do 1 million requests, which take 5 seconds, it will cost you nothing. If you do 2 million requests, it will take you 5 seconds to process them. It will cost you 20 cents. And if you do 10 million requests for 30 seconds, it will cost you $5.55, which is virtually nothing, right? Because who thinks of a request which takes up to 30 seconds? Nobody. So in our demo, if you do 100,000 screenshots with 15 thumbnails, it will cost you nothing, zip. And there are services on the web that will do this for you for like $100 to $200 for a set amount of screenshots. So yeah, there's that. So in conclusion, serverless is a really cool framework. It's a really cool architecture type, which you should, I think you should investigate. It's cheap. It comes with auto-scaling out of the box, so you don't need to do any effort for that. And I think it's going to be really big in the next couple of years. It's already big, but it's getting a lot bigger, and it's going to be a lot bigger in the next few years. I saw a tweet today from someone saying, okay, so cloud was like version 1.0, automating all that was version 1.5, and the serverless world is going to be version 2.0 of the cloud. So, yes. there's Tom Cruise. What? Any questions? Yes. Oh, there's a mic. Oh, wait for the mic.
No, it's super nice to see. I've been looking into it myself too. But what's your thought? Because it's relatively new, and I think there's going to be especially a lot of development on how to reuse all these functions that people made and made them because eventually you don't want to write it yourself. You want to pick them from some library or some framework of all these lambda functions.
Yes. Yeah.
Is there already some movements? Because I
yes.
haven't
So
seen.
what AWS actually announced at reInvent was the API gateway application. So this application that I built, you can now deploy into the AWS marketplace. You'll be able to look for it, and I can give it a price, say $1 a month or something, and then you can just say, okay, enable this in my local account, and it will install everything for you. So yeah, there's going to be a lot more movement in that space. Yeah. Yep.
I actually missed the step where you deploy it.
Oh, yeah. So
or it was so
that was a
blazing
bit more
fast,
scary for me because so if you go to my website, in the blog post, it will actually tell you a lot more in depth about technical details of all the different configuration stuff, and it will actually do the deploy with you. So this is actually all it takes, but I haven't set up my dev credentials here, so I can't show you that. So that's actually all there's to it.
That will create, do like the API calls to Amazon and package up your application.
Yes, it will package up everything, set up a CloudFormation script, upload the CloudFormation script, upload the S3 files, perform the stack update, and all that. And there is actually, I created a nice little button saying launch stack, which you can click. And then if you're logged in.
This will get it from the marketplace and do the whole thing.
Well, it's free.
Yeah.
Come on. It's open source. So now you can just say next. Let's call it foobar. Yeah, that's all right. Yeah, I'm done. Oh, yes, of course, it already exists. But so if you were in your own account, you could deploy it with this, and then you could look at it, how it's built, and yeah.
There was a name collision of foobar. How amazing! Unexpected.
Yes.
Another question. You ran out of test X, Y, Z.
Yes.
They were all
Everything is
gone
full.
already.
I learned at the reInvent to call things bananas because bananas are awesome. So.
Final question. Before we go eat mesh. We have all kinds of mesh. Mesh, normal mesh, boerenkool, zuurkool, sauerkraut for our German audience.
That was a question.
Hey, Jose, great.
Yeah. So you really don't have any other choice than to bundle all the dependencies that you need with the Lambda function.
Oh, no, actually you can. So I put them all in one file because it was easy for me and I could reuse some of the stuff. But you can actually just package everything in different files if you want to. Even use different NPM modules if you really want to. Yeah, you can definitely do that, yeah.
Yeah, because I'm just thinking about a simple case in that, let's say I have a function that needs to connect to an RDS and needs something like, the Python Postgres driver or something that requires compilation. So you have to bundle it.
Yes.
Are there any libraries that are available predefined on the Lambda function environment?
Yes, so if you just use the regular package.json files, you can actually just package all that in. And Serverless will actually take all those files, put it in the zip file with it, and then upload it.
Right.
So yeah, you can.
But how about the long-term running of this stuff? Because this runs in a virtual machine in the end with like a specific glibc version, and Amazon can't guarantee that because they have to update that kind of stuff because it can have a vulnerability.
Yes.
So at one moment in time, they'll all of a sudden decide, hey, we're gonna go for.
It's way often actually. So every if you spin up an Lambda function, it's invoked. Then the virtual machine gets started, and it will be running for the longest time is about 14 hours. And it just gets killed if it doesn't be used again. If you keep sending requests, that will be up. But yeah, there's definitely a time where they will just kill your function or your instance, and will start a new one. But that's the basic idea. You don't have state, So you can put something in /temp if you want to, but you shouldn't, because it can be gone like the next second, the next request actually. And actually you should design your application to be completely event-based. So store your state somewhere else.
Yeah, but then still, how do you make sure that your application keeps running while Amazon changes your tires and everything underneath, and all of a sudden, so you have like a binary in there, which is built against like certain versions of the OS, and then at Sunday night or it's Friday afternoon at 4 o'clock, Amazon tries to decide to deploy your application on a new virtual machine with like different versions, which your binary is not built against.
Yes,
so it will.
That's a problem. Yes, you're right. You can set. You can actually set for all the different.
I was just waiting for the moment that he said you're right.
So you can write functions in Python, Java, C# now, and Node.js. You can need to specify which version you want. So that's one of the things.
So for the runtimes, it's a bit safer, but then still for like packaging
for binaries, actually, the binaries is a hack. Because you actually shouldn't, because it's also it's not a form of state, but it's not.
But they specify it's running on Linux against x86.
It's running on there's an RSS feed that you can follow, and they'll say the newest Lambda functions will use AWS Linux version X, and you can just download that AMI, just spin up a VM with that AMI, compile your binary, and you can create CI/CD processes for that. But
cool. At least it can do like failure detection and page you.
Yeah, of course, yeah. And if so, everything you do in Lambda gets logged into CloudWatch, and you could put alerts on that. So if there's more than X amount of errors, they maybe want to send out an email or stuff like that.
Cool.
Call someone in the middle of the night. It's always nice.
Final question before we do MASH.
I want to have food.
Well, we're early. We're really early, and I don't want to piss off. Okay. Okay. Then please give a round of applause for Sander and.